Good morning. Rohini College of Engineering and Technology, aggregated with A+ grade by NAC, Department of Civil Engineering. C3402, Strength of Materials, Regulation 2021. A. Anand, Assistant Professor, Department of Civil Engineering. So here we are going to see the topic simple bending of beams. So in this bending stresses in beams, when an external load act on a beam, the shear forces and bending moments are set up at all sections of the beam due to the shear force and bending moment. The beam undergoes certain deformation. The stress induced by bending moment is known as bending stress. So here we can see the problems on simply supported beam. So already we have seen that our hanging beam. Now in a simply supported beam carries a uniformly distributed load of 40 kN per meter run over the whole span. The section of beam is rectangular, having depth as 500 mm if the maximum stress in the material of beam is 120 Newton per mm square. And the moment of inertia of the section is 7 into 10 power 8 mm per 4. Find the span of beam. So given, so UDL W is equal to 40 kN per meter, depth D is equal to 500 mm, maximum stress sigma max is equal to 120 Newton per mm square. Moment of inertia is equal, I is equal to 7 into 10 power 8 mm per 4. Section modulus Z is equal to I by Y max. So here Z is equal to 7 into 10 power 8 divided by 250 is equal to 28 into 10 power 5 mm cube. And next, maximum bending moment for simply supported beam carrying UDL is equal to W into L square divided by 8. By using, we are getting the value L is equal to 8.197 meter. And next, second problem, a timber beam of rectangular section of length 8 meter is supported. The beam carries a UDL of 12 kN per meter run over the entire length at a point load of 10 Newton at 3 meter from left support. If the depth is 2 times the width and the stress in the timber is not to exceed 8 Newton per mm square. Find the suitable dimensions of the sections. So given values, length 8 meter, UDL 12,000 Newton per meter, point load 10,000 Newton, depth of beam d small d is equal to 2b, sigma max is equal to 8 Newton per mm square. So this is the simply supported beam with the full of UDL. At a 3 meter distance you are having the 10 kilonewton point load. So for finding the reactions RB and RA, so RB is equal to 51750 Newton and RA is equal to 54250 Newton. And these are the shear force calculations at B is equal to RB minus RB. Shear force at C is equal to 8250 Newton. Shear force at C minus 18250 Newton. And shear force at A 54250 Newton. And maximum bending moment will occur at 4.3125 meter from B. For finding this, maximum bending moment is equal to RB into 4.31 minus 12,000 into 4.31 into 4.31 divided by 2. We are getting the value 11,585.93 into 10 power 3 Newton mm. And to find the section modulus of rectangular beam, Z is equal to BD cube by BD square by 6 is equal to 2B cube divided by 3. We are getting the conditions. We know that M is equal to Z into sigma max. That you are using the conditions, you are finding the breadth value 275.5 mm and the depth is equal to 551 mm. So these are the answers for breadth and depth. The unit will be mm. Thank you.